The estate has been in the same family now since 1492, so the same family for the last 500 years. The current owners took over in the late 50s, early 60s. Now when they took the estate on, it was really, really bad. The manor house was almost derelict. They were told to flog it, get rid of the whole thing and just forget it. Sell it to a hotel company, just dispose of it. And they decided not to. They decided to try and restore the house and the rest of the estate and get it going and get it functioning as a proper country estate once again. So it took them 6 years to get the house dried out and get it usable. The house was built in 1588, so it's Elizabethan. And as soon as they did that, they opened it to the public. So they opened it in 1967. And they then started on the rest of the estate as they go around. One of the things that they were looking at was something that was constant, that had always supplied an income through the estate's history, looking back through the records. There were two things. The estate was very well known for horse dealing, and it was also very well known for dairy herds. So Mr. Easton decided that's the one thing then that they would use as the base core of the estate finances. And we have a huge dairy herd here, and we supply milk to Marks and Spencer's. So our dairy herd is in the top 5% in the country for quality of milk. Now there is also the possibility, it's being looked into, I don't know how far down the feasibility side it's got, to use the cow poo to make methane, etc., and make reusable energy. So they're looking into that. There's a good chance that if they do, the herd will need to be increased up to 750, and we'd have to build a lagoon to actually control the quantity of manure that they basically create, which we now have the lagoon. So we are part way there if they decide to go down that route. But that's something that's been constant now. As far back as we can track, we've always had dairy herds, and we now still do. And Marks and Spencer's come into play as well with the turbine. But if you look at the mill historically, it's a very unusual mill. It used to have two water wheels, one on each side. The one we've got on that side, which is still there now, which you'll see in a bit, and one where the turbine is now. So for a long period of time, two water wheels, two sets of millstones. The millers were very wealthy people. For a rural mill, they did incredibly well for themselves because they had this double wheels situation. They could put a lot of flour through the mill, and they did incredibly well out of the plague in London as well, because any rich people moved out the city, moved to these areas around here, which were more rural, and they wanted white flour. White flour is expensive, rural mills don't make it, but this one decided to, and they made the millers a fortune. So that's why the mill came to be the size it actually is. Then by the time you get to the turn of the century, around about 1900, this side is no longer in use. They don't need it anymore. They've only got the water wheel working on that far side. And what they decided to do in the 1920s is rip all this side out and put in a turbine to produce electricity for the manor house. Because manor houses generally are built on the outskirts of towns and villages, etc. And your power supply was pretty atrocious. I think we had two working lights and a sort of kettle, and that was about it. That's all you could actually do. It was really quite poor. So by putting in their own turbine, they created their own electricity, once again using the power from the river. And we've still got bits of it sat on the island over there, so you'll see most of it when we go over. And that worked quite successfully up to the 50s. They didn't need it anymore. They got a good supply to the house of power, so it just fell into disrepair. They tried to get it going again in the 1980s, had a little bit of trouble with their ACs and their DCs, had a couple of fires, took the roof off, burnt a couple of walls out, gave it up as a bad idea and just left it. About probably about 5 years ago, the estate was approached by a gentleman who designs putting in hydro schemes like this, and he wants to know if the estate was interested in either renting the site out to him and he would cream the money off the turbine, or employing him to put it in for the estate. And in the end, Mr. Easton decided to have it put in for the estate, and the estate would take the revenue off the turbine. The turbine is there for a very specific reason from our point of view. Obviously, mainly we want it to generate cash, but for a very specific reason. The mill is a lot smaller than it used to be. It's missing an awful lot of buildings. We're hoping that the profit that comes off the back of that is going to pay for us to put the mill back to how it was 200 years ago. We are missing a lot of structures. Where you've got that funny angular building at the moment, that is temporary. That houses our computer system, and it's just there to keep it weatherproof until we get a bit of funding coming in and we can start to rebuild. But that will end up being an oak-framed granary with a dovecot in the end of it. Then beyond that there'll be an oak-framed barn, and then beyond that will be a wharf where the barges would come in and go to London. So this turbine is going to generate the cash for us to do that and put it back exactly as it should be. And then any surplus will go to the estate, and that will go for restoration work of the other buildings. So we started our consultation period really about sort of 3 years ago. Now, obviously to do that, we've got lots of relevant bodies involved, because the difference with us is we're not sticking it on a weir, it's on a listed building. that creates a completely different set of problems. So we had Society of Protection of Ancient Buildings, English Heritage, Environment Agency, South Oxfordshire District Council, Berkshire Council, Council of Preservation of Rural England, and the Fisheries. So we had 7 bodies that we had to get to agree to the way that we were actually going to do it. So what the land agent decided to do was do it round the other way. Get them all to agree first, and then once everybody was in agreement in theory and to a degree on paper, then put in your planning application. To save the amount of toing and froing, backwards and forwards, reapplying, councils going on holiday, can't get an application in until sort of September when they come back on holidays, etc. And it passed. First time, straight through, which was quite unusual. We have had the problems with, you can't do that, you can't stick that on the side of a listed building, that's sacrilege, you can't do that. But it is a commercial listed building, and that has helped us no end. Because it had water wheels, because it had a turbine in the 1920s, nearly 100 years ago already, it is a commercial building. It's never been a dwelling, it's there specifically to do something. Whether it makes someone a living or provide a service for the local villagers, that's what it's designed to do. If it stayed the same from day one, you'd have literally a 12-foot square room, thatched roof, 1 water wheel, set of millstones. That's how it started. But they added to it every century to get it to something that would make money. And that's all we've done now. We've put that in there so that those buildings won't want for any money for restoration work and maintenance. The turbine will provide the cash to do it. It's not going to solve everybody's power problems, we know that. But we are getting into a position where we're consuming more electricity than we could produce. We're running out of fossil fuels, that's a fact, whether we like it or not. If you could stick one of these everywhere where it was possible, where you've got a change in river level, as you all well know, at least we could possibly slow it down a little bit and give ourselves enough time to come up with a decent answer. So there is no reason to put it in. But there is a huge amount of red tape involved. It does slow things down no end. And it does help if you have a land agent who can deal with those side of things, as well as your engineers that can deal with the construction side. They are 2 very specialist areas, and they meet somewhere down the middle, but they do have their own areas which the others really don't understand. So they do need each other there. So we started our construction in April last year, and the idea was, the deadline was to get it done by October, because once we get to October, between October and March, that's when we flood. And one thing we didn't want was a soaking wet computer system, and we didn't want the water getting underneath the mill, because in order to put it in, we drained the river. We dammed it across the front, and we dammed it across the back, and we put a causeway in to get onto the island, and we drained the underside and got the mill completely dry so we could work underneath. Part of the reason we wanted to work underneath is because the mill dates back to the mid-1600s, it's not in a very good state of repair, as will become apparent. Now, basically, this is where we start. What we did on the other side of the mill is we put in a causeway. So we had 2 sets of sheet piling, filled it with about 60 or 70 tonne of crushed concrete, so we could drive the machinery to get it onto the island, because we need to get access from this side. So we had an 18-tonne 360 digger, which did most of the work for us, and then when the construction came, we're talking about an 80-tonne crane. So then what we've got where the turbine is sat now, this is the silt. We had 7-foot accumulation of silt. So we had a good few tonne had to be taken out, because we needed to get the flow of water onto the approach to the turbine so we could get a decent enough flow. The turbine's going to produce enough electricity. This lot had to go. So that lot had to be dug out. And you can see, once you start digging out, this is the side of the mill, and it's not in a very good state of repair at all. We've got lumps of brickwork which are collapsing. This is the core of the building, that is actually collapsing as well. And we actually we had to do a rebuild on that corner. We had a bit of a dispute with the council whether or not that was what was supposed to be done, and they served a notice on us to tell us that we were not allowed, we didn't have permission to do a brand new construction. We said, well, if it wasn't there, the flipping building will fall down. It's not a new construction, it's the corner of the mill. So we're still in a bit of dispute about that, and we had to do a retrospective planning permission. But as you can see, it's in a dreadful, dreadful state of repair. So by taking all the water out, it gave us the opportunity to get in and strengthen that side of the mill itself. And then they start to dig out the old 1920s concrete so that we could get where the old turbine was, and get this profile sorted out where this next one's going to go into place. Then we get to that, we start pouring our concrete. The other thing we found out once we started to pour concrete is across the front there, behind that retaining concrete wall across the front of that stable door, we had to dig the channel out to put the power cables in, which goes to the substation at the back of the house. In the bottom of the trench, a little hole appeared. And thought, well, we better have a look, see what's going on. Dropped a rod down there and it completely disappeared and it came up soaking wet. Had a good look down there, and the whole of the underside on this end of the mill, there is nothing under there at all, it's just water. There is no structure left whatsoever. Now we thought there was. There isn't. There's nothing, not even soil. So we stuck 15 tonne of concrete in there, and that is now a solid lump of concrete, and we've protected the corner of the building. Irrespective of whether that turbine was going in, we didn't know that, and we would have had problems in the future because we flood here very regularly. When we flood, you'd all now have extremely wet feet. And the back door of the mill is quite often left open and the water just comes pouring out. So if that happens and we've got nothing underneath it, it's literally standing on a few wooden stakes, that's potentially a disaster. So it has done us a backhanded good turn from the point of view of preserving the mill building itself. So the concrete pour starts, goes on for several days, worked extremely well. We were so lucky with the weather, it was unbelievable. The river was very, very low at its lowest point it's been for years. So we didn't have any problems with the water coming over the barriers we put up. Then we get our concrete profile in, we put our sluice gate in, solid steel gate. That's now holding the river back on the far side, while all the construction work is finished off on the inside. Switch around. Then the turbine itself actually turned up. Came on the back of a lorry, that's why when you came down the road there were no trees down one side of the road. Trees and lorry did not fit, trees had to go, turbine had to come. So the trees disappeared. They did have an order on them anyway for being unsafe, so it wasn't a dreadful disaster. We made sure they'd gone before this turned up. It weighs 24.7 tonne. It comes in basically the two sections. You've got your gutter, and then you've got your thread that drops in. On the actual construction, you've got a bearing at each end, gearbox and generator, that is it. There is nothing else. There are so few moving parts, as I'm sure you're fully aware, that makes them extremely efficient and very, very robust as well. Maintenance-wise, hardly anything at all. So, then we get the crane in, the crane takes it apart, takes the thread out, leaves the gully behind, puts them onto two smaller articulated lorries, drives them onto the island, then drops them into place. The thread itself, when it goes in, I mean, that gives you some idea of the scale of it. That is almost the same size as the back of the mill before it goes into the ground. It's absolutely huge when it goes in. And then this is our little tiny computer system. When we were told a computer system would control it, we all thought, oh well, nowadays that's going to be a laptop. They said, oh no, it comes on a pallet. I thought, oh well, 4 foot square. We turned up on a 9 foot by 4 foot pallet. That's to be brought in by crane, and then we found out it actually runs propulsion units on nuclear submarines. When you think about it, it makes sense. It's all to do with moving water. There's no reason not to. So it's designed by a company called Parker's. So the system went in, then they finished off building the building around it, made it a lot easier. And then the causeway gets pulled out, we allow the water back in underneath the mill, and we are basically in business. So by the time we finished, that's how we looked instantly, and that's how we looked when we started running before Christmas. Part of the reason for the bridge is historically it's correct, there's always been a footbridge across the front, so we've had it replaced with a nice oak bridge, as it would have been, but there is RSJs underneath it to strengthen it, obviously. And the other thing is as well, by putting that across the bottom bearing end, we deaden off a lot of the noise. The other thing we had to do was to be checked out by the council for noise pollution, because obviously we have houses nearby as well. And it also has helped out a lot of other people from the point of view of their feasibility study. Once we get it behind that building, when you walk up the side, you can hardly hear it at all. And when we turn the water wheel on the other side, there's not a great deal of noise difference between the two. And we've got a weir behind. So the noise it makes is negligible, you can hardly hear a thing. So that didn't become an issue, luckily for us. We know for other people it has been, but in our situation, we're okay. Now, we are a listed building, as I said. So the other thing we have to bear in mind is when the construction went in, it had to be altered in design and made squat. So it goes in within the building line at the end of the mill, but it still had to be made so we could get that original walkway back into place. When we started the construction, that was corrugated tin, asbestos and blocks of concrete. That's all that was left. So we've taken that out and we've put back exactly, according to photographs from around about 1900 and paintings, the structure as it should be, tipped up to the right angle so it gets onto the foundation line for the granary, which is above the floodplain where you store your grain. So it is absolutely correct. It looks atrocious. It looks like it's a really dodgy carpenter's put it up, but it's how it should be. That's why it's done the way it is. So that meant our drive shaft had to be shortened so we could get the gearbox and the generator in behind the thread and still get enough power out of it. So the thread is very wide, but it's very, very short. So it's an unusual shape. So obviously it's made specifically for us. It's It's made in Germany by a company called Rehart, and they met their deadline bang on. It turned up at the end of August. The cranes came at 9:30 in the morning, dropped into place, went home 3:30. So it went perfectly well, unlike we understand certain ladies at Windsor Castles aren't going quite according to plan, which is extremely satisfactory. The other thing, the reason why we wanted it done by October was because the Queens were supposed to go online in October, and Mr. Easton decided he wanted to be first. We were first, we turned ours on. They put theirs in, and they're still not connected up. So far, we've had this display board put up there. It's only went up last week very quickly. It's not calibrated correctly, but we've put into the grid since the middle of December 290,000 kilowatt hours, which to us is worth around about 60,000 quid so far. So another 790,000 pounds to go, and we're nearly breaking even. The lifespan is 20 years, 10 years payback, 10 years profit. So we're looking around about £1 million profit. That will put back all our buildings, that will get that mill back to exactly how it should be. And that's what it's there to actually achieve.
So what's its rated output?
Well, this is where the thing we had was we put a generator on there that will do 150 kilowatts an hour. The problem with that is, to get our decent tariff rate, we had to be under 100 kilowatts. Otherwise we start going into a different band for a commercial producer. So because we put in a larger generator, the electricity board said, but you can produce 150 kilowatts, we're not going to pay you. You get the lower rate. We said, yeah, but we put a larger one in because the maximum we can do is about 93 to 95 kilowatts an hour. We've done that so that we don't strain it and run it flat out. If we'd have had a 100 kilowatt generator, it'd always be running at maximum and we wouldn't get the lifespan out of it. So we had to provide several months worth of data to them to prove that we cannot physically do 100 kilowatts an hour. And now we've proven that, they're paying.
Is it pretty much running 100% of the time to capacity?
We found it's extremely efficient in the sense that if the river level changes by 10 mil, that's the difference between us running at 50% and 100%. So we only need a slight variation in the river level for us to go flat out. The problem we have is we are under licence to the Environment Agency because obviously we're moving water, and we have an extraction licence. We are not extracting, we are diverting. The principle is the same in the sense that what we are doing is putting water outside of the Environment Agency's control. Because obviously anything goes over the weir, they can control it. They can drop boards in, they can take boards out, they can open gates, but if it goes around the side and goes through our turbine, it's out of their control. Now, they said, well, we're not taking it away, we're putting it straight back in the tanks this year. If we get a drought situation and we want to hold the river back because the flow rate is so poor, you're going to let it through. So if you're under licence, we have the right to tell you to turn it off. So although the system operates on river level, we are controlled under licence by cubics, by flow rate. So our flow rate, we must operate below 5.2 cubics at the monitoring station at Reading. But we can at the Environment Agency's discretion. So although coming up to Christmas we had times when the flow rate was absolutely atrocious, it was really bad. Because we run on a variable gearbox, if we set the control figures, the barriers right, we can run at a lot lower flow rate than that and not affect anything. We are providing a constant line on the graphs down at Caversham Bridge, which is our next point where we send our water to. We aren't affecting the river, we are going with it. So what our sensors in the river do, we have a sensor connected to the computer, which is connected to a variable gearbox. As the river goes up, this will speed up, as the river goes down, it will slow down. Purely and simply because of that lock. We have an enormous lock next to us. He drops the river level 30 millimetres in 4 minutes. The problem we had was the computer system didn't understand that, and every time the river dropped dramatically, it absolutely freaked out. And it used to run at 200%. It sent water over the bridge rather than under the bridge. It put water up against the mill, it sent it through the drainage holes under the floor, straight underneath the mill, straight out as 2 jets to the other side into the water wheel. It just couldn't cope with the fact that the river could drop so fast. So we had the computer program altered so it understands fluctuation from wind and boat traffic, and also debris occasionally coming up against it, and huge drops in short space of time. Then it knows it's the lock, and it will slow down to 10%. Let him take the water. As soon as it notices a recovery, it will speed back up again. As long as it never stops, it doesn't cost us anything, because obviously it consumes electricity to run the computers and to start it up. And we didn't realise how much it actually consumes, and in our first month of playing with it, we got sent a bill for 60 quid from the electricity board, because it actually costs so much to start it and stop it, because we get it running at a certain speed before we introduce the water to it. So that means the generator goes the other way, fires it up, gets it going, then we introduce the water, then the generator goes the other, and the power goes up the cable. So we want to make it so that it never stops. So that's the idea. So we go with the flow of the river, but to be honest, at the moment it's running around about 90%, 92%. The boats are going in and out a lot. The level is now coming back down. So as the boats pass through, we are slowing down, letting the boats through, and then speeding up again. But at night we run flat out. Winter time we ran flat out for 3.5 months solid, 100% non-stop, 24 hours a day. So it is doing, in theory we're supposed to do 500,000 kilowatts a year. We're just coming up to 290,000 since December. So we're about bang on our target. If we do 500,000 kilowatts a year, we're on target to make money. So the engineers got it right. We're quite pleased so far, touch wood, provided nothing goes wrong. We'll go and have a look.
You know, I video record all of that. Should have done with the other ones.